Classmates, today we are going to introduce the methods of subnetting. Before we introduce the basic methods of subnetting, let's review the function of the network mask, also known as the network mask. The network mask is mainly used to determine whether hosts on a network are within the same subnet. The calculation method involves performing a bitwise AND operation between the host's IP address and the network mask, resulting in the network address. If two IP addresses have the same network address, it indicates they are on the same network. And when they are within the same local area network, they can communicate directly. We know that Class A, Class B, and Class C IP addresses are commonly used IP addresses, suitable for different network scales. A Class A network can accommodate up to 16 million hosts, while a Class C network can only accommodate 254 hosts. With the development of computers and advancements in network technology, personal computer applications have rapidly become widespread, leading to the proliferation of small networks, especially small local area networks. These networks may have as few as 10 hosts, or as many as 2 or 3 hosts. For such small-scale networks, even if assigned a Class C address, it would still be wasteful since each Class C address can accommodate 254 hosts. As the number of local area networks and hosts in networks increases, IP addresses are becoming insufficient for allocation. People began to seek new solutions to overcome IP address waste. The solution was to adopt subnetting techniques, dividing one network into multiple subnets, while appearing as a single network externally. Subnetting is a technique that uses variable length subnet mask (VLSM) technology, which involves changing the length of the subnet mask. This technology is highly effective in efficiently utilizing IP addresses and reducing the size of routing tables. But what exactly is subnetting? Subnetting is the process of dividing a larger network into smaller networks, which are referred to as subnets. Specifically, subnets are created by borrowing host bits from the main network address. The advantages of subnetting include reducing network traffic, improving network performance, and simplifying network management. Now let's take a look at the specific method for subnetting. The process of subnetting involves 2 steps. First, determine the number of network bits for the subnet address, starting from the highest bit of the host portion in the network address. Convert some of the host bits into new subnet bits, while leaving the remaining bits as host bits. The number of subnet bits can be determined based on the number of hosts required for each subnet. For example, if a subnet needs to accommodate 20 hosts, then according to the formula 2 to the power of n-2, where n must be greater than 20 and closest to 20, n would be 5. So, the subnet will have 5 subnet bits for the host portion. During the process, it is important to remember one concept. Regardless of how many host bits are used as subnet bits, you must ensure that at least 2 host bits are reserved. This means that each subnet must have a minimum of 2 available IP addresses. The second step of subnetting is to determine the subnet mask and address the subnets. For example, for the network address 172.16.0.0, with a mask of 255.255.0.0, we will borrow the first 8 bits of the host portion for subnetting. This means the available range for the subnet bits is 000000000 to 1111111. As a result, the subnet mask becomes 255.255.255.0, and the subnet address range becomes 172.16.0.0 to 172.16.255.0. Each subnet will have 8 bits left for the host portion, allowing each subnet to accommodate 254 hosts. Next, let's specifically talk about what variable length subnet mask (VLSM) means. VLSM stands for variable length subnet mask, which is also known as in Chinese. In a main network, multiple subnets are defined, and each subnet may use a different mask length. This allows for effective utilization of the existing address space. Take a look at the example topology diagram. The network planner has divided the 172.16 Class B address into multiple variable length subnets. Some subnets have masks with 24 bits, some have 30 bits, and others have 27 bits. Next, let's take a look at the calculation of variable length subnet mask (VLSM). The calculation of VLSM is similar to subnetting, where we continue to borrow bits from the host portion of the subnet to create variable length subnet bits. For example, consider the subnet address 172.16.32.020, where there are 12 host bits. We can borrow 6 bits from these 12 host bits to create variable length subnet bits, leaving us with 6 remaining host bits. In this way, we can list the main network bits, subnet bits, variable length subnet bits, and host bits. Following the example, we can obtain 6 variable length subnets as follows: 172.16.32.026, 172.16.32.6426, 172.16.32.12826, 172.16.32.19226, 172.16.33.026. Finally, let's take a look at classless inter-domain routing (CIDR). CIDR allows us to move away from using standard Class A, B, and C IP addresses, and the differentiation between network bits and host bits will be entirely dependent on the network mask. CIDR supports route aggregation, which can merge multiple entries in the routing table into a single entry, helping to conserve IP addresses and address the problem of growing routing tables. Above is the content of our class today. Please complete the following assignments after studying. Calculation question: the subnet address 172.16.128.020 has been subnetted with a longer subnet mask to 172.16, 128.26. Please write down the respective subnets after the subnetting.